All right, welcome. In this video, we are going to take a look at some patterns related to the periodic table and the organization of electrons within atoms. So it turns out that electrons are not just kind of randomly jumbled around surrounding the nucleus. They actually exist in certain locations, and we call those locations shells. So shells are these areas where electrons exist. And we're going to be looking at some models of the atom that look a little bit like this. And in this model of the atom, this dense area in the middle, that is the nucleus. Remember, the nucleus is where the protons and neutrons are. And that is where all the mass is located in the nucleus. And then the electrons, and remember this right here, this symbol E minus is the symbol for electrons. They exist surrounding the nucleus, and they turns out they are organized in these things that we call shells. They look like rings. Some you may have heard them called like orbits or orbitals, but we're going to call them shells. Those are just areas where electrons are. And we want to be able to look for some patterns as to how many shells different elements have and how many electrons are in each shell. So what we have here on page 12 is there's a partially completed periodic table, and we want to look for patterns in the number of shells and how many electrons are in each shell, and we want to use those patterns to kind of fill in the blanks here. So that's the goal behind this lesson right here on page 12. So let's take a look at it. So if we look at our partially filled in periodic table, some things that we might know is that, things we might notice is that, for example, everything in row 2 has 2 shells. You notice that? Everything in row 3 has 3 shells. So if you go all the way across this row, all the ones that are filled in have 3 shells. Everything in row 4 has 4 shells, and everything in row 1 has 1 shell. So what that tells us, it looks like we can use the row number to determine the number of shells that an electron will have. Sorry, that an atom will have. Number of shells in an atom. So we want to fill in the blanks here, like beryllium is in row 2. It's going to have 2 shells. So I'm going to draw those in. 1, 2. Carbon's also going to have 2 shells. Aluminum's in row 3, so it's going to have 1, 2, 3 shells. Chlorine will also have 1, 2, 3 shells. And then in row 4, I've got calcium. We've got 1, 2, 3, 4 shells. Arsenic will also have 1, 2, 3, 4 shells. So that's one important pattern that we want to notice. Another pattern we might notice, it has to do with what column they're in. So if we were to go through and number these columns, 1, 2, 3, 4, 5, 6, 7, 8, you would notice that everyone in column 1, they all have 1 electron in the outer shell. Everyone, group 2, we only have one example, so we can skip that for now. But notice over in group 3, they both have 3 electrons in the outer shell. Over here in group 4, these both have 4 electrons in the outer shell. Group 5, they'll have 5 electrons in the outer shell. 6, we see a pattern here. 7 has 7. Now we can go back here probably with 2 and say, oh, probably everything over here is going to have 2 electrons in the outer shell. So here's another pattern here. And this last one is the only one that doesn't quite match the pattern. So these 3 all have 8 electrons, but this one is an exception. And helium is just kind of an odd exception. But in general, things in group 8 have 8 electrons in the outer shell, with the exception of helium. So that's the other important pattern that we want to notice is when you look at the column number, will tell you the number of electrons in the outermost shell. And the electrons in the outer shell, we refer to them as valence electrons. So those are our valence electrons. And so let's kind of summarize this. So how does the number of electron shells correspond to the periodic table? Well, the row that you were in, or the period that you were in, tells you how many shells you will have. So for example, if we're looking here at magnesium, magnesium is in row 3. So I would expect magnesium to have 3 shells. This is the kind of thing we want to be able to do based on the periodic table. All right. So we know magnesium had 3 shells. Now let's talk about the idea of valence electrons. So let's kind of give you a definition again of valence. I kind of wrote this on the earlier slide. I just want to make sure we're clear on what we mean here by valence electrons. So valence electrons are the electrons found in the outermost shell. That's referred to as the valence shell. And core electrons is everything else that's not valence. So if we look at this atom right here, it turns out this is aluminum. We want to know how many valence electrons it has. Those are the ones that are in the outermost shell. So this atom has 3 valence electrons. Okay. Core electrons are going to be everything that is not valence. So since I'm looking at a picture of this, I could just kind of add them up. So 2, 4, 6, 8, 9, 10. It looks like there's 10 core electrons. The other way I could do this is I could do some subtracting. So the core electrons are going to be the total number of electrons minus the valence, because everything that is not valence is going to be core. So like in this case with aluminum, I could say, well, I know from looking at the periodic table, if I look over here at aluminum, aluminum has an atomic number of 13, which means it's going to have 13 protons and 13 electrons. So we know there's 13 electrons total in this picture. So I could say, oh, I've got 13 electrons total, and 3 of them are valence. So that means I must have 10 core electrons. So that's another way you could figure out the core electrons by doing some subtraction. We just did it here by counting, but I just wanted to show you that. Okay, so that's what valence electrons are, the ones in the outermost shell. And we can figure out how many valence electrons something has by looking at what column it's in on the periodic table. So remember, we were able to figure out that magnesium has 3 shells because it's in row 3, and it's in column 2. So that means it's going to have 2 valence electrons. So based on its location on the periodic table, we can predict something about its structure. It is going to have 3 shells, and it is going to have 2 valence electrons. So that means there's going to be 2 electrons in the outer shell. And this kind of shows those 2 electrons right there. And we tend to care more about the valence electrons than the other electrons, because the valence electrons are on the outside, and they're the ones that are kind of interacting with the rest of the world. So these are the ones that are going to impact properties such as bonding and reactivity and things like that. All right, so that's a summary. And you can also take a look at page 13. There is a reading that can be helpful as well. Let me know if you have any questions.